Beneath the sparkling blue waters of New Zealand's largest lake lies a colossal threat powerful enough to change the course of human history. Lake Taupō may look peaceful, an idyllic getaway framed by forests and distant volcanic peaks. But its calm surface hides the most explosive volcano of the past 5,000 years. A supervolcano capable of unleashing more energy than hundreds of nuclear bombs. Nearly 1,800 years ago, Taupō erupted with such violence that it blasted ash high into the stratosphere, darkened skies across the Pacific, and left a geological footprint still visible today. And 26,000 years before that, it produced one of the largest super-eruptions ever recorded on Earth, an apocalyptic event that reshaped entire landscapes and plunged vast regions into a volcanic winter. Today, scientists know that Taupō is far from extinct. Beneath the lake, magma is slowly gathering, the crust is stretching, and the ground periodically rises and falls, as if the Earth itself is breathing. Swarms of tiny earthquakes ripple beneath the caldera every few years, a quiet but persistent reminder that this volcanic titan is still alive. What would happen if Taupō awakens again? How much warning would we really have before a new mega-eruption changed New Zealand, and possibly the world, forever? Let's find out. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Taupō's origins stem from the dynamic processes of the Taupō Volcanic Zone, a 350-kilometer-long rift stretching from White Island in the Bay of Plenty to the volcanic peaks of Ruapehu and Tongariro in the Central Plateau. This region lies at the boundary where the Pacific Plate is subducting beneath the Australian Plate. But unlike many subduction zones that create volcanic arcs with towering, symmetrical cones, the central portion of the Taupō Volcanic Zone is undergoing extension, meaning the crust is being pulled apart. This stretching allows hot, silica-rich magma to rise from deep reservoirs and accumulate in large underground chambers. Over hundreds of thousands of years, the Taupō magma system grew to immense proportions. Periodically, the pressure within this chamber became too great for the crust to contain, triggering colossal eruptions that expelled hundreds of cubic kilometers of magma in single events. Each of these eruptions drastically reshaped the landscape, emptied the magma reservoirs, and caused the ground above to collapse, forming the caldera structures that the modern lake now fills. Taupō's identity as a supervolcano is tied to these rare but cataclysmic VI7 and VI8 eruptions. These events dwarf even the largest historical eruptions, such as Tambora in 1815 or Krakatoa in 1883. A VI8 supereruption releases more than 1,000 cubic kilometers of material, enough to bury entire continents in ash and alter global climate patterns for years. The most significant of Taupō's eruptions was the Oruwanui event, around 25,500 to 27,000 years ago. This eruption is classified as VEI8, one of the largest known volcanic events in the last 70,000 years. The eruption devastated vast regions of the North Island. Pyroclastic flows, scorching clouds of ash, gas, and volcanic debris swept across landscapes at hurricane speeds, annihilating everything in their path. Ash rained across the entire North Island and far into the South Island. This event fundamentally reshaped New Zealand's geography. The eruption drained and redirected river systems, created new valleys, and left behind vast and imbright sheets that still dominate the central landscape today. When the underlying magma chamber collapsed, it left a massive depression. This caldera later filled with water, forming the Lake Taupō we see today. Around 232 CE, Taupō produced another enormous eruption known as the Hatape eruption. This event, classified as roughly VEI7, was one of the most violent eruptions seen anywhere in the world in the last 5,000 years. Although smaller than the Oruwanui event, the Hatape eruption was still large enough to alter landscapes, disrupt ecosystems, and leave a geological record of tremendous energy release. The eruption column is thought to have reached more than 45 kilometers into the atmosphere, a height that would disrupt global aviation if it happened today. The Taupō eruption also produced tsunamis within the lake, seismic shaking, and widespread ashfall. Areas surrounding the lake were buried under layers of thick ash, reshaping the topography and creating the fertile volcanic soils that now support forests and agricultural land. Importantly, this eruption occurred during human recorded history. It demonstrates that Taupō is not just a prehistoric system, but an active threat that has erupted on a massive scale within the last 2 millennia. Though Taupō has not produced a large eruption for 1,800 years, the system remains active. Modern monitoring reveals signs of unrest that indicate ongoing magmatic and geothermal processes beneath the lake. Seismic swarms periodically rattle the region, often consisting of hundreds of small quakes clustered beneath the lake or surrounding rift structures. In late January 2025, a notable swarm of over 50 earthquakes was recorded just north of Lake Taupō in the geothermal area. The strongest of these quakes measured around magnitude 2.8. A wider study of the 2022 to 2023 Unrest episode documented one of the largest magnitude earthquakes under the lake in at least 50 years, around magnitude 5.7. These quakes are typically caused by magma movement, gas accumulation, or adjustments in the crust as pressure changes beneath the caldera. Ground deformation, subtle uplift, or subsidence of land around the lake also occurs episodically. Scientists have identified a partially molten zone beneath the Taupō region, suggesting that the volcano still contains significant magma bodies at depth. The crust in the central Taupō volcanic zone is unusually thin, facilitating the ascent of magma. Hydrothermal vents and geothermal systems around the lake offer additional clues to ongoing volcanic heat and movement. Taupō is currently classified as a potentially active volcano. Geological records indicate that eruptions smaller than VEI-7 are far more common than super-eruptions, suggesting that future activity, if it occurs, is most likely to be moderate-sized, though still hazardous. The key question is whether Taupō could produce another VEI-7 or VEI-8 eruption in the future. The honest scientific answer is yes, but the timescales involved complicate any predictions. Super-eruptions are extremely rare. Globally, a VEI-8 eruption might occur only once every 50,000 to 100,000 years. Taupō's last VEI-8 happened roughly 26,000 years ago, and its last VEI-7 occurred about 1,800 years ago. Geological systems operate on scales far longer than a human lifetime, so even though these events are spaced out, they do not rule out the potential for another large eruption at some distant time. However, the chance of a super-eruption happening in any given century is extremely low. Large eruptions require immense volumes of magma to accumulate, differentiate, and pressurize over millennia. Scientists expect that any buildup toward a massive eruption would likely show clear warning signs years or even decades beforehand. Still, the Taupō system does not need to reach VEI-7 or VEI-8 to produce a hazardous eruption. Even a VEI-5 or VEI-6 eruption, similar in scale to Mount St. Helens in 1980 or Pinatubo in 1991, would have catastrophic regional consequences in New Zealand. Such eruptions are far more plausible within human timescales. New Zealand's authorities operate an extensive monitoring system around Lake Taupō. This includes seismographs to detect earthquakes, GPS instruments to measure ground deformation, lake-level sensors, gas monitoring, hydrothermal surveys, and satellite imagery. All indicators feed into New Zealand's National Volcanic Alert System, which provides early warning information to civil defense authorities and the public. Monitoring aims to identify early signs of magma movement or pressurization. In many volcanic systems, significant unrest precedes major eruptions. These warning signs can include swarms of earthquakes, rapid uplift, increased gas emissions, or changes in hydrothermal activity. While volcanoes do not always behave predictably, The scientific consensus is that a catastrophic eruption would likely provide detectable precursors well in advance. Although no monitoring system is infallible, New Zealand's Volcanic Observatory is one of the most advanced in the world, offering reassurance that Taupō's mood will be closely watched. New Zealand's Taupō supervolcano is a geological marvel, a system of immense destructive potential hidden beneath one of the country's most iconic lakes. Its history includes some of the largest eruptions ever identified, explosions that reshaped continents, altered climates, and reconstructed entire landscapes. Yet it also coexists with thriving communities, flourishing ecosystems, and a vibrant tourism industry. The story of Taupō is not one of immediate danger, but of deep time. Its cycles of magma accumulation, eruption, and dormancy unfold over tens of thousands of years. Humans witness only a fraction of its timeline. While a super-eruption is possible in the distant future, it is not expected anytime soon. The greater likelihood lies in moderate-sized eruptions that, while still hazardous, are manageable with preparation and monitoring. As long as scientists continue to monitor, model, and study its complex system, humanity will be better prepared for whatever future Taupō chooses to reveal.